Okay, so when you're taking the limit, first thing you should do is try plugging it in. And honestly, sometimes it's that easy. So number one, from your homework, is the limit as x approaches -3. So remember that this means we're approaching that value from both sides, and then we will look at the y value and see what's going on, right? But technically, we can also just plug it in and see what happens, because I don't see any hole or issue with inputting this value. So honestly, you don't actually need the limit. You can just say plug in a value, right? So this would be -3 times -3, which is a 9. 9 times -3 would be a -27. Okay. Alrighty. See how we found the limit without doing anything. You see what I'm saying? You don't have to approach it from both directions because there was no issue with the value of -3.
So I had a question about that one. Like it is very simple,
Mhm.
but when I stick my calculator, it comes out to -4 because I have two. The limit is approaching -2, and when I plug it into my calculator, it comes out as -4. But the actual website doesn't take -4; it's -4. Is like, is that the website, or is it just is there like something I'm not understanding?
So you're cutting off a lot, but you said you had -2 here,
Yes, sir.
and you had and the it was still cubic.
Yes, sir. It was two.
So then, oh, sorry, this is a 2 as well.
Yes, sir.
Oh, okay. So yours would simply be
Four.
yeah, -2 squared, which is 4. Yeah.
Yeah, but the website just doesn't allow -4. It only like accepts normal 4. Right.
Well, it should be 4, positive
Yeah,
4.
yeah, but that's what I was saying though. Is that like I know it's 4, but when I plug my calculator, it comes in just plugs in as -4 though. But I was thinking that's just
Oh,
calculator, right? Because it
yeah,
accepts it
yeah.
wrong.
It's because the parentheses must be around the -2. If
Huh?
you put the negative out here, it would turn out to be -4.
Okay, that makes
So
sense.
so when you punch in the calculator, make sure that the parentheses are around everything, just like we did here, right?
Yes, sir.
That makes sense, or
Yes, sir.
okay, cool. All right. You guys have any other questions? Go on to the next one, number 2 here. This looks like the same deal. So when you do these problems, I want you to ask yourself, is there any problem with me plugging in 1? Do you see an issue?
No.
No,
Mm,
right?
one's fine.
Yeah, 1 looks okay, right? Because it doesn't create 0 down here. There is no
Right.
negative in the square root, whatever. So this literally means you can do it, which would give us 1/3, right? So the first thing you should do whenever you're asked to find a limit is we'll check and see, can I plug it in? And if you can't, then graph it and see, okay, what's going on here? Is there a hole? Is there something weird? And then if you can approach it with a graph, great. If you can't, then you can use the other approach from last section where you plug in numbers really close to 1. Like in this case, it'd be like 1.001, 1.01, whatever, or 0.9, 0.99, etc. Does that make sense?
Yes, sir.
Okay, 3 is pretty much the same deal. I'm gonna skip that. This one, try to do at least 1 or 2 from each category in the homework so you have examples. Now that it's not now that it's getting more in depth, I guess. Let's look at number 4 here. Number 4 says find the limits of f and g. Okay, cool. Let's find the limits. Given, I'm going to rewrite the problem a little bit better. Given that f is x plus 2 and g is x squared. So let me show you the problem. In all honesty, there is not much to do here. It's similar to the last two that we did. Can you guys see the question from your homework?
Yes, sir.
So check this out. Like plugging in 3 doesn't actually do or create any problems for f, right? You can plug in anything you want. So yeah, 3 plus 2 is 5. If I plug in -4, doesn't create any problem here. So -4 squared is 16. It's nothing to do here. Other just like number 1 and number 2, you just plug it in. C is a little bit different because it's requiring you to do a composition. So let's do C. I'm going to skip A and B, let you do that. So the limit of x approaching 3 of g of f, that means the limit as x approaches 3 of g of x plus 2, right? So this means I'm going to plug in the x plus 2. Let me switch back. Right? Plug in the x plus 2 into x squared, because that's g. So that would give me the limit of x plus 2 squared as x approaches 3. Now this new function that we created by composing g and f, does that have any issues with 3?
No.
No, so there's not much to do here either. So we just plug it in. So once you take the limit, you no longer write the notation of limit. You just simplify. And that's it. So that probably wasn't even worth doing in my opinion, but there's number 4 in part C. Any questions on the first 4 so far? Seem okay?
Did you do the last part of it?
I did all of part C, yes.
I'm sorry, I guess I like kind of lost where the compressed part was. Like it's the first part, right?
Yeah, so here it says compose G with F, right? So you're going to input the F
Right.
into G. So G of F would be squaring F. Oops. So that's when we squared it. So I could have distributed that too, but I can also just plug in the 3, right?
Oh, okay. I see what you're saying.
It would be the same either way. All right, let's go back to the homework. So number 5, 6, and 7 are the same kind of deal. So let me do one of them. Number 7 has you break down every little step along the way, which is what I'm going to do with numbers 5. Okay. 6 is the same thing. It's just instead of a square, they have a cube. So you're going to have to factor this with the sum and difference of cubes formula. So you'll need that for this top part. Over here, we only need the difference of squares. All right, so let's do number 5. Oops, didn't mean to do that. Oh well. All right, so this is an analytical technique using algebra to find the limit of the function if it exists, of course. So the limit of x squared minus 9 as x approaches -3 of x plus 3. So you agree that right now, if I plug in -3, I'm going to have division by 0. Do you all see that?
Yeah, I see it.
So I can't do what I did with 1 through 4. So we got to figure out, okay, so one thing you could do is graph it and look from the left and right like we did last section, but we're doing analytical techniques, not graphical. So let's not do that right now. But you could technically. So what I'm going to do is factor the bottom using the difference of squares. So this becomes x plus 3 times x minus 3 over x plus 3. So I factored the top. Once you factor the top, you're going to cancel, leaving you with just this piece. I no longer have that problem area. I guess I don't need a bar anymore. So if you plug in -3, what do you get?
It would just become, it would just be x equals 3, right?
Yeah, you just plug it in. So -3 minus 3. It's -6, right? So this right here would be the simpler function. This is the limit. Because they'll ask you on part A and part B, what's the limit? Well, here it's right here. And this is the factored form, the simplified form, I should say. Any questions on 5? So we use algebra to remove a problem.
So -6 would be the actual answer, like you were saying.
Yeah, -6 is the limit.
Gotcha.
Now, if we were to have used Desmos to graph it, I bet we could see it. Let's check it out. Oops. So the number they asked for was -3. So let's go ahead and mark that. So there it is, right? If I approach from the left, I'm getting closer to -6. Approach from the right, I'm getting closer to -6. So yeah. So graphically, it's the same. And we did it analytically on paper. You guys cool with number 5?
Yes, sir.
Okay.
Yes, but what about the second part of it?
The second part is what asking for this. See how we simplified it? And everything canceled. They want this piece.
They want the x minus 3 part?
Mhm.
Oh, okay, okay, got it.
So whatever you, when your question, whatever it reduces to, that's what you put.
Okay, thank you, sorry.
All right. I'm gonna skip 6, 7. It's the same thing. Nine looks, or 8 looks, it's the same technically, but a little more challenging. So let's do 8. Then we'll move on to something different. A different technique with algebra. So find the limit. Find the limit of this guy. So I'm gonna have to use a difference of squares on the bottom, and then on the top, I can try this standard trinomial factoring, right? So let's see, because right now if I plug in 3, I'll get 3 squared, which is 9. 9 minus 9 is a problem. Let's not do that. So I'm going to get x minus 3 times x plus 7. Yeah, that'll work. Over x plus 3 times x minus 3. I don't want to gloss over the factoring too much, but it's assumed you know how to do this. But do you guys remember how we factor the top and the bottom?
You have to like multiply to the last number, right? Like 7 times 3 equals 21.
Yeah, so the -3 times 7 must be -21. And then when you add them, -3 plus 7, it needs to add up to the middle term, the b, which we call.
It's the FOIL method, right?
Yeah, we're basically reversing the FOIL. So if
Oh,
you
okay,
multiply this out, foiling this would give me that. So we're factoring and undoing a FOIL. We're undoing multiplication. And down here is a difference of squares. That's just a formula. So when you see the examples or other examples, just remember difference of squares, sum of cubes, difference of cubes. Those are the 3 that you're going to see more than likely. Anyway, so these cancel, right? So if I plug it now, I should be able to plug it in. So plug in 3, that would give me 3 plus 7 over 3 plus 3, which is 10 over 6, right? Which would be 5/3. Yeah. Any questions on number 8? All right. So let's do something different. So a new technique. So one technique to do an analytical approach is to factor. Okay, another technique is to multiply by a conjugate. Okay, so that's the first technique. 5 and 8, we used factoring. So this is number 9. So the limit of the square root of x plus 6 minus 3 x minus 3. So whenever you see a square root plus something or square root of something minus something, I'm going to write a note here. Use conjugate. Now, what is a conjugate, right? A plus B and A minus B are conjugates of each other. So basically it's just something plus something or something minus something. And then you have the exact same thing, but different sign in the middle. Okay, so the conjugate of x minus 3 would be x plus 3. That's all this weird word means. Is that clear?
Yes, sir.
Okay, so I should probably rephrase this, multiply. By the conjugate. Okay. So you always choose the one with the square root, because when you do a conjugate, you create a difference of squares on purpose. This is what happens when you multiply a conjugate. A plus b times a minus b gives me a squared minus b squared. So if I'm able to square this piece, I will no longer have a square root part. Okay. This is a limit is approaching 3. Forgot to write. Okay, so conjugate for this case is square root of x plus 3. Well, I'm gonna phrase that better. I don't like how that sounds. Conjugate of the square root of x plus 6 minus 3 is square root of x plus 6 plus 3. So this is the conjugate of that. All right. So we're going to multiply the top and bottom by the conjugate. That's how you simplify the problem. And then hopefully something cancels, which allows you to take the limit. So this is the technique. Okay. Top and bottom. You guys still with me?
Following.
Yes, sir. Sorry, someone's spamming me, distracting me here. All right, so what we're going to do is multiply these using the conjugate. So you could FOIL all that out, but you should know that it's always going to be the a squared minus the b squared. So let's just go ahead. And I'm not going to do anything on the bottom just yet. So this square, which is the reason I did this, will cancel the radical. That's what we want. Do you see where we're headed? So then once you do that, right, combine the 6 and the 9, x minus 3 will cancel with that x minus 3. So I no longer have an issue
taking the limit at 3. So that's how this technique allows us to take the limit. Is that clear?
Yes, sir. Quick question, like in the very beginning, like if it's X, if it's like +3, then you just flip it to -3 on the beginning.
Yeah,
Thank you.
conjugate would just be the opposite
Okay,
of whatever you have. Just switch the sign.
all right.
Maybe I showed too many steps, but just in case.
I'm sorry. I'm lost.
Sure. Where did I lose you?
Um,
In the beginning or middle?
I guess the middle. I'm trying to go as you're going, but doing my problem, and I don't know. I'm kind of lost.
That's okay. So, so you understood what I chose a conjugate to start with, right?
Yes.
And then the formula tells us that when you multiply it out, you'll be left with the first term squared minus the last term squared. So whatever the a and b are will be here every single time. Squaring this gives me x plus 6. Squaring that gives me a 9, right?
Yes.
So 6 minus 9 is a -3. So I haven't done anything to the bottom. I'm just letting it come along for the ride, right? It's all the same. But once I've combined these guys, I get x minus 3. So factor, so I'm sorry, so then this factor cancels that factor, leaving me with a 1. Is that clear?
Yes.
So once you're here, you can just plug in the number and you're done. But something needs to cancel on your example once you get to this point.
Okay.
But I recommend you don't mess with the bottom at all because you want it to cancel. Did that help or no?
Yes. Thank you.
Okay. And any other questions on this problem?
The other reason you got rid of the x, like the square root of x plus 6 plus 3 on that second part was because you foiled it, right? That's why you, like, I don't know how to explain it.
You just take the limit, right? You put the 3 in there.
Oh, no, not that part. At the very top, you know how you went from like having parentheses square root x plus 6 minus 3, and then and the other side, it was square root of x plus 6 plus 3. The reason why you got rid of the x plus 3 is because you squared it, right? And that's why it's minus 3 parentheses 3 square.
Was it this step?
No, up,
This step?
go up, up.
Here.
Yeah. So you know how on the first step above, it's
Mhm.
square root of x plus 6 and then plus 3 on the
Oh,
side? Yeah, the
middle.
reason why you got rid of it is because you just square rooted it, right? And then you put 3 on the outside.
You're talking about the why this reduced to this?
Yeah.
Okay, that happened because of the difference of squares formula. So if you do all the FOIL, you'll see it, but I don't recommend doing that. So basically what I'm saying is if you have x minus 2, x plus 2, it's always going to be x squared minus that 2 squared. So whatever is in there, whatever this is, goes in here. So that's what the formula that I use up here at the very top.
Okay.
Difference of squares allows us to skip that work. So square this one and square that one. It's always minus in the middle. If you do this times this, this times that, and you just do every single thing, the middle terms will cancel, leaving you with this anyway. So there's no point in multiplying it out. The helper and example. Okay. So that was the conjugate technique. Now there's a formula that you're gonna need for the next one. You guys are all cool with number 9, right? Let me know. Or forever hold your peace, or I'm just kidding.
Which problem is this?
This is just a formula at the moment, but we're gonna do 10 in a second.
Professor, do you have a formula sheet for us to print?
I'll send you one once we have a ton of them. But I can send you some algebra stuff if you like all the algebra formulas.
Yes, that would be amazing.
Sure, yeah, I'll do that.
Okay, thank you.
I shall. Probably tonight, if not tomorrow. Okay. So this formula is this is a calculus formula for limits. So if you have sine x over x, it will always be equal to 1. And there's a proof in the book as to why, but we won't worry about that right now. If you're curious, we can do it, but otherwise I'm not going to. So if you see anything that looks like this and it's going to 0, it's going to be 1. Or you want to, if it looks close to this, you want to do your best to make it look like this and then take a limit. So that's what number 10 is doing. So number 10 says find the limit of the following. So as the limit of x approaching 0 for sine x over 3x. Looks like we can almost use that formula, right? Because it says it needs to be x, this argument right here inside the sign needs to be the same on the bottom. Currently I have an x, but down the bottom I have a 3x. It is not the same. So that 1/3 is kind of messing it up, right? You see that? So what you can do, since it's just a constant, you could pull the 1/3 out and then just apply your formula. Oops, let me write that better. So this will become 1. So it'll be 1/3 times a 1, which will be 1/3. Does that make sense?
How did you pull the 1/3 out?
So you can pull any constant in front of a limit. That is one of the limit properties, which I will also send you. There's a few of them.
And we got 1 from that formula. That's how we were applying it to this problem, right?
Yeah, so we use this
Okay.
one and
So-
applied it right there.
Okay.
Sine 0 on the circle, the triangle circle. Do you remember that we used to have it? It was like a circle and it had the sine 1 and
The
then
unit
like
circle?
units. Thank you. Sine 1 equals 1, right? And then the bottom, if whatever number it is, it just goes over. That's how you 1/3, right? Because sine x is 0, sine 0 equals 1, and then the 3 just goes across, right?
Well, not exactly. It's sine of 0 would be 0. But I can't plug in 0 because there's a 0 down here. But if you want to know why it's 1, we could go through the proof really quick. Let me show you. So if we go back to unit circle days, right? We know that sine x has to be between 1 and -1, right? Do you remember that? The biggest it
Yes.
ever gets on the circle is 1. And if I were to graph it for you, which I will in just a second. So sine of pi over 2 is 1. So the highest it ever gets is 1, and then it starts to repeat itself forever. The lowest it ever gets is -1. So the sine function is bound between 1 and -1 forever. That is the range, the lowest and highest points. Okay. Which is why I said over here that sine of any x will always be between 1 and -1. Do you agree with this statement?
Yes.
Now, if I were to divide everything by x and took a limit and said, well, if I let the limit of all this stuff right here, well, actually, let's do it in pieces. If we let x approach 0, i.e., let the limit of x go to 0, then what would happen here?
Would be 0. It would go to 0, right? I think.
Yeah, these would, well, actually, 1 second. That would be, one second. I forgot the formula. Where is it?
Would it be on the unit circle?
Well, this right here came from the unit circle. This first part.
Oh, I was just saying, because I have my unit circle with a bunch of like stuff on here.
Yeah, let me, one moment. Let me look at this and then I'll check your circle. I was trying to find a clever way to show this, but it looks like I was mistaken. It is not simple. It might take too long. Where is it? I think graphically might be best. Let's do that. Here. Yeah, this will make more sense. So this is sine x over x, right? We both understand that we cannot plug in 0, right? We all understand that that's a problem, correct?
Yes.
So if we go check it out ourselves, we'll see undefined. There is a hole there. But if we approach from the left and approach from the right, the y value we're approaching when we get closer and closer to 0 is 1, right? So that is the reason That's the reason this formula will be 1 without getting too deep into it. Sin x over x will be 1 when x approaches 0. So knowing this fact, you can start solving problems like this. So you just have to manipulate the, the question and make it look like the formula. That's all you have to do. Is there any questions on that?
No, sir.
So we did not use the circle technically. We just used the graph. But because if you could plug in 0, you would get 0, not 1. Sine of 0 is 1. Sine of 0 is 0. Okay. The next one, number 11, is the same thing. You just have to do some algebra. So I'll leave that for you. See this here? So basically you have to change tangent into sine over cosine and cancel and simplify the problem and then use the formula I just gave you. Sine of the fourth will be similar. Any questions on 11? You guys see that, or would you like to try it out?
I think we should try that one out. That one just
Looks
looks
weird.
kind of intimidating. Yeah.
Okay, let's do it. I'll leave this idea for another time. All right, so I will send you the limit properties and some basic algebra properties sometime after class, okay?
Thank you so much.
So find the limit. I'll write this question down. Of this following here, the limit as theta approaches 0 of cosine 3 theta tangent 3 theta. Okay, so real quick, we'll just work with the top so we don't have to write so much. Cosine 3 theta times tangent, which will be our scratch work, is equal to cosine 3 theta. Let me switch over, I forgot. So I'm just going to write this numerator on the side, and we're going to simplify the numerator, and then we'll plug it in just to be a little save some space. Tangent will be sine theta or sine 3 theta over cosine 3 theta. So that is definition of tangent, right? You guys remember this?
It's a reciprocal, right?
It's just a quotient of sine over cosine. It's always sine over cosine. So whatever's in here goes right there.
Did I say it like in the right terms or was it like a different way?
Reciprocal would be secant. So the reciprocal of cosine would be secant, or and vice versa. But this is just a third function. So it's just the main three functions, right? Sine, cosine, tangent, and then the other three, the remaining three will be the reciprocal trig functions.
Okay.
But this guy will cancel, right? Leaving you with sine of 3 theta. So let's go back over here and get back to our actual problem. Once we simplify it, we got sine, which is what we wanted because we can use that formula. We said it needs to match, right? 3 theta over theta. So I need a 3 down here. So how would I put a 3 down there? How do I force it?
Oh, you could use the, you could use multiplying by that.
I think you could
Multiply.
take, but what'd you say?
I wasn't sure if that was right. I just assumed because last time you took the top and multiplied it by top and bottom, but I don't think that would make sense actually. Now I'm thinking about it because I think that only works squares.
Yeah, you could multiply, you can multiply the top and bottom by anything you like, except 0, as long as it's the same thing. So I think we can use your, I think you're technically close. So if I multiply top and bottom by 3, I'll have what I need, right? You see what I mean? So now I have 3 sine of 3 theta over 3 theta. So this part right here, I can apply the formula to. Does that make sense? I can pull out the 3 to make it make a little more sense, I hope. So this will become, this 3 is just waiting for us. So the limit becomes a 1. 3 times 1 is 3. If any questions on the algebra at the beginning or the algebra to use the formula? All right, I'll leave the rest to you then. So that's pretty much 2, 3. Any questions on any of the problems we talked about?
Pretty self-explanatory by the walkthrough so far.
Okay, on the sheet. So let me look up some formula sheets real quick.
And after class, you post the videos right onto YouTube, right?
Yes, usually right after or
Okay.
a little bit after. I have 3 classes back to back on Monday, Wednesday, so I try to do it before I go to bed, but we'll see.
Where'd you pull the 3 from? With 3 sine?
So you saw how I introduced the 3, right?
Kind of where I got lost.
So remember how we said you can multiply top and bottom by whatever you like. I chose 3 in order to force the argument of sine to match the denominator. So once you have the same thing on top inside the sign and on the bottom of the fraction, you can apply your formula. The formula being this guy. So as long as these match, you can do it.
Oh, okay, that makes sense. Yeah.
So I forced it to match. That's what I did. Alrighty. So here are all the formulas you're going to need for calculus. I'm going to open it up and so you can see it. I download it from the chat box if you can. If you still need it, I'll send it to you as well. Just let me know. So here they are. These derivatives will be chapter 3, so I wouldn't worry about this right now. Anything with the ddx, all that stuff is chapter 3. So limit stuff that you need is right here. Properties of limits. So this says you can pull out any constant in front of a function and then take the limit. right? That's what this is saying. You can have a limit of two separate functions and then separate them and do them separately. So I can find the limit of f first and then add or subtract the limit of g and just do it separately. Same thing with times. It's not as helpful, but you could technically do limit of f times limit of g. So if you know, let's say you know the limit of f is 0, right? You can just say, you know what? I don't care what number that is. 0 times that will be 0. As long as it's not infinity, you could do that. Division, same deal. And powers. So if you have a power on your function, you can pull the power out of on front of everything, do the limit inside. So let's say you find the limit of f to be, I don't know, 3, like we just did. You would then apply the power. So if that power was 5, you'd do 3 to the 5th as your final answer. Okay. So these are all the limit properties in your book, and we'll be using. They'll still come up randomly. I don't think we're going to use them in depth, but it's good to know them. Okay, so please save that for me or for yourself. Let me see, I have an algebra somewhere. This might work. Here's a lot of the algebra properties, and let me find a factoring. you as well. You guys able to click the PDF or anything? Or no?
Yeah, I was able to get into it.
Yes.
Okay. Now here we go. Sorry, it took me a little longer than I thought, but this top one is all the ones I was talking about, square, some difference of squares, etc. It should be more than enough. But let me go over it real quick. So the very first one are the factoring formulas. So a plus b squared is always going to be this. A minus b squared is always that. Now see how if you have a difference of squares, it will always factor it this way. Difference of cubes will factor it this way. So you'll need mainly need these three, this bottom three to factor. I don't think you'll need the quadratic formula, but there it is, just in case. I think that is all. All right. Do you guys have any other questions on 2-3? I think that was it for 2-3. So 2.4 is when we start talking about just find the limit of one side, in other words, right side or left side. So I've been kind of talking about it along the way already, but we're actually going to find them this time. So look at number one. This is 2.4. So we're finding the limit. See, it says C plus. That's a stupid question. Let's find well, why don't you just leave it as C, lazy SOPs? Oh well. Okay, so C is 6, right? When and our function is this line F. So when we're approaching C from the plus, so if you see that plus, they mean right side, because that's the positive side, right? From this direction is C plus. C negative would be approaching C from the left side. In other words, this way. Does that make sense? The notation for C plus and C minus?
Yes.
Yes.
Now, if these are equal, the right-sided and the left-sided limits, If those are the same, then the limit will be, then the limit would exist, which would be the same thing. So since the limit is 3 from the right? I'm approaching 6, here's 6 from the right. So I can annotate a little bit. So here is, right, my 3. Here's my, so when I'm approaching from this direction, that is the C plus. When I'm approaching from this direction, that is C minus. Now, if they are the same, and you can see it, right? As I get closer to C6 from the left, the function is going to 3. My approach from the right is still the same. Since they are equal, then the limit will be 3. And yeah, that's what happens, right? So they got a 3 and a 3, so therefore 3. Now the question is the function continuous at 6? So this is a little more in depth. Let me find a little note here, 1 second. Where is it? Oh, here it is. Yeah, give me 1 sec. This is 2.4, right? So he said. All right. Here we go. So before we start, let's define continuity formally. To pull out my dusty calculus book. Continuity and one-sided limits. So I already showed you what one-sided limits are. We'll do a bunch of those in a moment, but the continuity is a little bit more in depth. So definition. For continuity at a point. So a function f is continuous at C when these 3 conditions are met. So all 3 need to be met. So f of C is defined, meaning that I can plug in the C into the function without any problem. It is not undefined, it is defined. Number 2, the limit of f of x as x goes to C exists. So the limit must be the same from right and left. The third condition, the limit of f of x when x is approaching C must equal the same thing as plugging in C. Okay. So we need this to answer that continuity part, because it said, is it continuous at x equals 6, right? So it asked. Do you see what this notation is saying? Any questions on this definition here? Is it clear? Can you read it?
Yes, sir.
Okay. So let's go back to the question. Does it match all three? Does it have all three conditions? So number one, is the function f defined at 6? Is there a hole?
No, there's no hole.
No, right? So number one is good. Number two says, does a limit exist? I'm like, well, yeah, we just explained that, right? Left and right side are the same, therefore the limit exists at that value 3. Now, number 3, is the limit the same as plugging in the number? The limit is 3, right? When you approach 6, if I plug in 6, I get 3, therefore, yes. So it matches all three conditions in order for it to be continuous at a point 6. Does that make sense? Is that okay? No, we'll do number 2 next. It's just for the practice. Okay, well, moving on to 2 then. Number 2 says use the graph to determine the limit. Now, notice there is a hole this time, right? Can you see the hole?
Yes.
So that means it fails number 1. This function is not defined at C. C is -2, there's -2, right? So there is my -2. So for sure it's going to be no, because it failed number 1 on our definition for continuity. Now look at the limit from the left side. So approaching from the left. So this is my, this is this guy right here. That's this one. As I approach from the left, what is the y getting closer to, right? It's going to be 2. Now from the right, this is the right side, the plus. So I approach from this direction, the positive direction, right? That's this one. It is going closer and closer to 2. So that's why it's also 2. If they are the same, then the limit exists, which will be 2. Is there any questions on this idea?
No, sir.
Do you see, does everyone see, well, I guess let me know if you don't see why it's not continuous at -2.
It's just not continuous because it has a hole, right? It has a hole in it.
Pretty much, it fails number 1. The whole means it's not defined at
So, like,
C.
So like if you were like to read this as a question and it didn't come to the graph, like usually I think this you're supposed to figure out if it is continuous or not by the left and right side not eating the same. So if it's just a question with more information on whether there was a hole, or would it just come with like exactly like just
Yeah, I mean, as long as it fails one of those three requirements, so let me show you. So if I fail any of these three, it's not continuous at that C that they're talking about. In this case, it's talking about C equal to -2. So it failed number one. But yeah, if you said you said if the limit didn't exist, right? Or if they were different, then that would mean it didn't exist. So it would fail number two. And let's say that the limit does exist, but the f of C is a different number. If they don't match, then it's also not continuous. So as long as one of them fails, then yeah, we're screwed. Not continuous. Let's move on. Now look at number 3. So this is more theory. Limit from the left. C is 1, so 1's right there somewhere. Make a little note here. So here's 1, right? So if I approach 1 from the left, my function is going to 4, right? If I approach 1 from the right, I got to go down here. I'm approaching -4. These limits are not the same. The left and the right are not the same. Therefore, the actual limit does not exist. Okay, so I'll make another note here. If the limit of some function from the left side, let me write forgot the x part. As x approaches C from the left is not equal to the limit of f of x of as x approaches C from the left and the right, sorry, then the limit of f as x approaches C does not exist. Okay, so if the left and right are different, the actual limit does not exist. That's what happened with number 2. They were not the same. And since the limit did not exist, it is not continuous because that's number 3. I'm sorry, number 2. Number 2 says it must exist at C. But if that fails, which it did, then not continuous. So not continuous. Does that make sense, or?
Yes, sir.
Okay. How much time we got left? A little bit of time. Okay. Number 4, it's only asking for a left-handed limit. It's not asking for both sides or a regular, it's not asking for a regular limit or both sides, just one side. What is it, right? So we could graph it and just see. Can you guys see the grapher?
Yes, sir.
It was, I already forgot the function, shoot. X over x squared. X over x squared. It was -9, is that what it was? Yeah. Okay, so it was approaching x equal to -3, right? From the left side, so -3 from the left. So x equals -3. So there it is. So as I approach it from the left side, it shoots out down forever, right? So it's actually an infinite limit, which we'll talk about in the next section, I think. So that'll be, so you'll say it does not exist in this case. Just goes down forever. Okay. So that's all you have to do for these questions is either graph them and then check what's happening on the right side, check what's happening on the left side. If it asks for continuity, then you have to go through these 3 requirements and see if it passes all 3. Passes all 3, then it is continuous at a specific point. If it fails any of them, you say not continuous. Okay. So on this guy here, as well, is it, if it's just continuous at x equal to something, they want to know where. So if you graph it, you'll see it. Although they gave me the graph here, so -1, right? There's a hole there. So that fails number 1 of our definition. So -1. Anyway, let's stop here because I know it's a lot of information. So I want you to, if you can, please watch the videos that I posted a while back, so you can have more theory and start practicing. And then I'll see if you guys have questions on 2.4, and then we'll move on to 2.5, 2.6 on Wednesday. Okay. You guys have any questions in general?
No,
No, sir.
Okay. Then let's call it a night, and I'll see you Wednesday.
Thank you so much.
See you later.
Have a good one.